Hey everyone, it's Mr. Vargas here, looking to check in with my Math 8 students and try to help them with tonight's homework assignment, which is homework 1.5, page 47, and we're working with negative exponents. So we watched that video in class today, we took some notes, we did some examples, so hopefully this is a good reminder of how we do these types of things. Okay, negative exponents. We'll start with number 1. We've got 7 raised to the negative 10 power, and we're simply asked to write this or rewrite this thing, whatever this is, this base and this power, rewrite it using a positive exponent. Now in class, I shared that, you can't just change it to a positive exponent, make it 7 to the power of plus 10. That won't work, so we have to do something else. And that involves writing this original thing as a fraction. So we can always put 1 underneath any whole number. So I'm going to change it to that. 7 over 1, 7 to the negative 10 over 1. And then in class we learned that if we want to change this to a positive exponent, what we have to do is actually flip these two guys so that we end up with 1 on top and then 7 to its power on the bottom. But now since we flipped it to the bottom, we can actually go ahead and make that negative 10 a positive 10. Okay, so that's number 1. Let's try number 2. Number 2, a little bit trickier, not much. So you've got negative 5 to the negative 4th power. And this one we can rewrite it as a fraction with 1 on the bottom. And we know to change a negative exponent, which is right here, negative 4, we want to make that a positive 4. We're going to have to switch these guys, take their reciprocal or do a flip. So the 1 would end up on top. And here's the part where it's kind of tricky. This negative 5 just stays the same. The base stays the same. The base stays the same. But that exponent, sure enough, gets changed to a positive exponent. And that's your answer for that one. Number 3. Okay, we did it with numbers. Now we can do the same thing with letters. If I have G to the negative 7th, and I want to rewrite that, I'm just going to have 1 on top, and I bring my base and its exponent down and change that exponent to a positive. So there is your answer right there. All right, let's go to some of the harder problems. Let's take a look at number 9. Zoom, zoom, zoom. Number 9. So we've got this thing right here, 0.1, and they're asking us to change that into a negative exponent. You might be wondering, what the heck? How do I do that? How do I change a decimal to a negative exponent? Well, I'm here to tell you that negative exponents basically are decimals. They're very similar. So let's look at the number 10, and let's raise it to the power of negative 1. 10 to the negative 1. Now earlier we did some problems, we did some examples, and we learned about how we can make that become a positive exponent. And that's simply by writing 1 on top, putting my base and its power on bottom. So now we have 1 over 10 to the 1. And 1 over 10 to the 1 is just going to be 1 over 10, because we just multiply 10 by itself one time. So 10. And if you remember, what's 1/10 written as a decimal? 1, and we need it to be in our tenths place. So 1 over 10 is the same as 1/10. And hey, look, what do you know? That takes us back to this original statement right there. So these two, 0.1, I'll circle these in purple. These two things, 0.1 and 10 to the negative 1, are actually identical. They're the same. Okay, so for this problem, we've got 0.1, and we already know that's going to be equal to 10 to the negative 1. We've also got 0.01, and here's a trick. Basically, you take your decimal and you count to the right until you get after your 1, and that is going to be your negative exponent. So here we go. I'm going to move the decimal once, twice, so my base is going to be 10 to the negative 2 for twice. Okay, so we've also got this problem right here, 0.001. Alright, if I had to move my decimal, I would move it once, twice, 3 times. So this is actually going to be 10 to the negative 3. We'll learn about this more later when we explore scientific notation. And then the last one was this. Okay, if I had to rewrite that, I could move the decimal 1, 2, 3, 4, 5, 6 times to get it behind the 1. So that means that number, 0.000001, is equal to 10 to the negative 6. All right, awesome. Let's go ahead and move to number 11. Now we have this thing right here. 2 to the negative 3 times 2 to the negative 4. All right, we can actually simplify that. But first, let's rewrite this with positive exponents. So 2 to the negative 3 is the same thing as 1 over 2 to the third power. Right? We just flipped it and changed it to a positive. And then 2 to the negative fourth is the same as 1 over 2 to the fourth. Okay, we can multiply our fractions straight across the top. 1 times 1 would give us 1. And then we can multiply straight across the bottom. 2 to the power 3 times 2 to the power 4. Well, we know when we multiply with the same base, we just add our exponents. Oops. Okay, which is equal to 1 over 2 to the 7th. So you could leave it like that, 1 over 2 to the 7th. Geez, I can't draw today. 1 over 2 to the 7th. There we go. You could leave it like that, or you can go ahead and actually simplify 2 to the 7th. You can punch that into a calculator, and that would get you 1 over 128. So I'll accept either of those answers. Another answer that I'll accept is actually going to be 2 to the negative 7th. Right? Because negative 3 plus negative 4 gets you negative 7. These three things are all the same right here. I'm going to circle them in green. This is equal to this, which is equal to that. Those are just 3 different ways to write the same thing. Okay, let's go to number 12. So you've got s to the negative 2 times, sorry, it's s to the negative 5 times s to the negative 2. Okay, so here when we multiply bases that are the same, we can add the exponents. Negative 5 plus negative 2 makes negative 7. So that would get you s. So when we add those exponents together, we get s to the negative 7th, right? Or if you want to write that using positive exponents, we can flip it down to the bottom. Those two things are the same. Awesome. All right, a few more, and then we will wrap it up. Number 14. Number 14 is actually a little bit tricky, not too bad. So remember, if a number does not have an exponent next to it, there's always an understood 1. So we can put a 1 next to the 3, 1 next to the a, and then we can actually do our multiplication. We're doing 3a times a to the negative 3. Okay. We can also put a 1 in front of this a. So we would do 3 times 1, or 3 to the 1 times 1 to the 1, which is just 3. And then we're going to multiply a to the 1 power times a to the 3rd power. Base is the same. Add the exponents. 1 plus negative 3, or negative 3 plus 1, will get you negative 2. So a to the negative 2. Now, if you wanted to rewrite this using only positives, you could keep the 3 on top, put a 1 on the bottom, And then you're actually going to just move this part right here in the green. You're just going to move that down. So the 3 will stay on top, but now the a to the negative 2 is going to come down here, and it will take the place of the 1 and become a positive exponent, a to the second power. So there is your answer in, let me use gold. Okay, last problem. Let's jump to number 15. Okay, so here we're asked to simplify this, and we can do that by getting all of our 3's, all of our base 3's on the same, either top or bottom, on the same line. So let's take 3 to the negative 5th, and let's move it up to the top. So I'm going to keep my 3 to the negative 1 on top. Come on. Oh man, the pen's not working. 3 to the negative 1 on top. Okay. And then I'm going to write 1 on the bottom, and now I'm going to move that 3 to the negative 5 up to the top. That will change it to a positive. Alright, and then from there we can simplify. This is going to be equal to, hey, this is multiply 3 to the 1 times 3 to the 5. We can add our exponents. Negative 1 plus 5, or 5 plus negative 1, would get you 3 to the 4th over 1. And 3 to the 4th over 1 is just the same as 3 to the 4th, which is just actually going to be 81. Because that's 3 times 3 times 3 times 3. Alright, and that's your answer. That does it for this video. We'll see you next time.